फिर से स्वागत है आपको। मैं गौतम आज एक सिविल इंजीनियर। आप देख रहे हैं स्ट्रेंथ और मटेरियल का लेक्चर सीरीज।
Today we will discuss about deformation of member under axial load and corresponding stress of each member due to this axial load. There are total 4 cases. Case 1 bar of uniform section, case 2 stepped bars, case 3 bars of varying sections or bars of carrying varying forces, case 4 deflection due to self weight. So at first we discuss about case 1 bar of uniform section. For that case diagram is like this. Here length of this bar is L and due to applying this load P, deformation is del. We need to find out this deformation. From this figure we can say that here stress equals to load by area, that means P by A. Here A means area of this cross section. We know that the relations between stress and strain, that is sigma equals to strain into E. Here strain equals to, you know, that changing length by original length. Here changing length del and original length L. So I just put this stress and strain value on this relation. So from this equation we can say that del equals to PL by AE. So that is the value of the deformation of this bar, that is delta. Here we already calculate stress because there have only one force, that is P, and this area A, that's why stress equal to P by A. So that is the first case. Now we will discuss about second case, and that is stepped bars. So for case 2 diagram is like this. Here from this diagram we seen that in this total body there are three parts, that is AB and BC and CD. For AB part there are a cross sectional area A1 and modulus of elasticity E1 and length L1. For BC cross sectional area A2, modulus of elasticity E2 and length L2. For member CD cross sectional area A3, modulus of elasticity E3 and length L3. Here due to this applying load total deformation is del. Here this load is PD is outward, that is joint D, that is PD, and that is joint C, that is downward, and PB, that is inward of this BA member. So we have to determine the value of this deformation del, that is total deformation. Here del equals to the deformation of member AB, that means del AB plus the deformation of member BC, that means del BC plus the deformation of member CD, that is del CD. At first we have to determine the force of each member. So we have to draw free body diagram of this total body. For this type of case we always draw free body diagram from free end. That means at first we draw free body diagram of CD member, and that is here on CD member downward force PD and due to this downward force there have an equal and opposite force, that is also PD. Now we draw BC member. This total body is hanging here on C point, total force act, that is PD and PC. Both load act on this point. On CD member only PD is act from this point, that's why we denote this PD from this point, and here from C point both force act, that is PC plus PD. So there are also equal and opposite force, that is PC plus PD. Now we discuss about AB member. At point B total force act, that is PC plus PD, total downward force and upward force, that is PB. So at point B we can write that in this direction, because PC plus PD, that is upward direction, and if we cut this cross section at this point, that is downward. So that's why we write PC plus PD on this direction, PC plus PD, and opposite side force, that is PB, so minus PB. So there are an equal and opposite force, that is also same, that is PC plus PD minus PB. If you have a confusion about this force direction, then I clear it very accurately. That is, so from this figure, if we draw free body diagram, then suppose to denote that that is first member, that is second member, and that is third member. So we said that previously for this type of case we calculate from free end. So at first we draw third member, that is here there have a applying load in this direction. So if we denote this by PD, that is PD, so in opposite direction there have a load, that is also PD. Here PD act upward in this joint, that means PD act upward. So we know that each action have an equal and opposite reaction. So from this second member there have an opposite reaction. So if we draw second member, then from this PD also act in this direction, that's why this direction is downward, that is PD plus, that is act PC, so that's why PD plus PC. That means two force act, that means PC already applied on this joint and PD transfer from D joint to C joint. So total load on second member, that is PD plus PC. Here in second member, total load PD plus PC. So this force is equal and opposite of this member. So here also PD plus PC. So we reach point B. So now we draw first member. So here in joint B, PD plus PC act upward. So due to this applying load on this joint, there are an equal and opposite reaction from AB member, that is this, that is downward. So from B point, PD plus PC downward. Here PD plus PC act downward from this first member, and here also another force applied, that is upward, that is PB. So total resultant force, that is PD plus PC minus PB. So that's why we denote this, that is on this direction. So PD plus PC minus PB. So equal and opposite force act on opposite side, that is same. So PD plus PC minus PB. So here we get each member force. Now we calculate del. So here is seen that del equals to del AB plus del BC plus del CD. So here del AB equals to, we know that del equal to PL by AE. So in first member there have a force, that is PD plus PC minus PB, that is total force applied on first member into length of first member, that is L1, by area of first member, that is A1, and modulus of elasticity of first member, that is E1. So del AV, we find del AV. After that we determine del BC. Similarly, that is force, that is P equal to PD plus PC. So del BC we can also determine, and del CD, that is PD, that force is PD. So del CD we can also determine. So you can easily determine del equals to del AB plus BC plus CD. In stepped bar case there are a different case, that is like this. For this case we have to determine total del. So we have to determine first each member deflection. Suppose we denote, that is member 1, member 2 and member 3. So for first member we at first draw free body diagram. We start from left side. So first member, on this side, that is the value of 5. So there are equal and opposite value, that is also 5. Now we go to second member. On second member, that 5 is in opposite direction. And there have an applied force, that is 2. So resultant force, that is 5 minus 2 equals to 3. Now we draw member 3. On member 3 there have an opposite direction force, that is 3, and here applied force, that is 2. So total force 5. So in problem they have also given, that is 5. So we determine the value of force of each member. So we have to determine now del. So del 1 equals to PL by A. Here everything known, that means area also given, E also given, and L also given, and already we determine this force, axial force, that is P. For each member we determine P. So we determine del 1. So we can determine del 1. Similarly we can determine del 2 if A, E and L is given. And similarly we determine del 3 if there have AEL given. And stress, how can I determine stress? Stress equal to force by area. We know that sigma equals to P by A. So we determine each member force. So from this member force we can say that suppose in first member there have a force that is P5, and area, if area is given, then we can determine easily that stress, we can determine stress easily. So that is the second case. Now we discuss about case 3, that is bars of varying section or bars carrying varying forces. At first we discuss about bars of varying section. Diagram is like this. From this diagram we see that in each section cross section is varying. Here we consider a small strip on this diagram, that is dx, that is from free end, the distance is x. So for this case we have to determine del, how much deformation is occurred on this case, that is del. So we know that del equals to PL by AE. Here area is a function of x, that means due to change of this length area also change. So for each area del is different, so we have to integrate along this total length. Here P is constant in each section. Here area is varying with respect to length, so area is the function of x. So at first we can write that for this small strip d delta equals to P into dx by ax into e. That is for this small strip, because a is a function of x, and we apply load only this dx length, that's why length only we consider dx. If we want total deformation of this diagram, then we have to integrate along 0 to L of this d delta. So total del equals to 0 to L P dot dx by function of x, that is area, into E. Here how can I put the value of x? Suppose we consider at support area is A1 and at free end area is A0. So for L length, changing of area A1 minus A0. So for L length, changing of area A1 minus A0. For unit length, changing of area A1 minus A0 by L. And for x length, changing area A1 minus A0 by L into x. So we can put this area on this place and calculate del. Now we discuss about bars carrying varying forces. So diagram is like this. So from this diagram we see that there are different value of force on different section of this body. For this case, consider a small strip on this body, that is dx, from free end, that is x. So we already know that del equals to PL by AE. Here P is the function of x, Here p is the function of x, that means with changing length p also varying. So we can write that p equals to function of x. So for this small strip, small deformation, d delta equals to px into small strip dx by area is constant and L, that is same. So that deformation is for small strip. If we want to total deformation of this body, then we have to integrate from 0 to L. So total deformation equals to 0 to L, sorry, that is E. So we get total deformation for varying force. Here in both case we also determine stress, because in first case P is constant and we also determine area. So stress equal to P by A, that is we can determine stress in each section. And also there have another case, that is force is different in each section. So here have also for each section stress equals to P by corresponding area. Here area is constant, only force is changing. So in first case we can write that stress equal to P by Ax, where area is the function of x, and in second case stress equals to Px by A, where A is constant and P is varying with length. So now we will discuss about case 4, that is deflection due to self weight. The diagram is like this. From this diagram we seen that length of this diagram is L and the unit weight of this material of this diagram, that is gamma, and A equal to cross sectional area of this diagram. Again we say that del equals to PL by AE. So for this case total weight act from CG. So that is a symmetrical material. So that is a symmetrical body, and CG distance from base, that is length by 2, that means half of this length. So here total load W equals to total length into area, that means total volume, into unit weight, that is gamma, that is total weight of this body. And del equals to what we know, del equals to PL by A. Here P equals to W and L, that act only from CG, that is L by 2, and AE. So del equals to WL by 2AE. Here this load W act on this L by 2 length, on which side, that is along upper side, because load act downward, that is from CG, and this load act along upper side length. So that is final deformation of this case. So next day we will discuss about true stress, true strain, engineering strain and their relation.
अगर वीडियो अच्छा लगे तो जरूर लाइक कीजिए। अगर कुछ क्वेरीज है वीडियो के रिलेटेड और सिविल इंजीनियरिंग रिलेटेड तो कमेंट कीजिए। आपका फ्रेंड्स, रिलेटिव्स, क्लासमेट्स और अदर्स सभी को इस नॉलेज की जानकारी फेसबुक, व्हाट्सएप, ट्विटर, इंस्टाग्राम किसी भी प्लेटफॉर्म पर शेयर करके हेल्प कीजिए। वीडियो को एंड तक देखने के लिए सच्चे दिल से आपका बहुत बहुत धन्यवाद।